minimum burial depth for a bonding conductor is 12 inches from the ground surface. If the polyvinyl chloride conduit is buried at least 12 inches deep, the bonding conductor can be installed within the conduit. However, the bonding conductor must be securely attached to the polyvinyl chloride conduit throughout its entire length. The National Electrical Code does not require sealing the bonding conductor connections. However, in corrosive environments or where the connections are exposed to moisture, it is recommended to use a sealing compound for added protection. Table 300.5 applies to exposed equipment and readily accessible unprotected equipment. Since the bonding conductor is not exposed or readily accessible, Table 300.5 does not apply. The bonding conductor should be installed in accordance with Article 250 of the National Electrical Code, which covers grounding and bonding. The bonding conductor should be connected to the grounding electrode system for the pool equipment. The bonding conductor should be sized appropriately for the maximum fault current that could occur. Proper bonding of an in-ground pool is critical for safety, as it helps to equalize the electrical potential in and around the pool, reducing the risk of electric shock. The bonding conductor creates a low impedance path for fault current to flow back to the source, tripping the circuit breaker or ground fault circuit interrupter and to energizing the circuit. Article 680 of the National Electrical Code provides specific requirements for swimming pools, spas, and hot tubs, and it's essential to adhere to these regulations to ensure compliance and safety. The purpose of bonding is to create an electrically safe environment for swimmers and those around the pool. It's also important to understand the difference between bonding and grounding. Grounding provides a path for fault current to return to the source, while bonding connects metallic parts to create an equipotential plane. Firstly, all metallic parts of the pool structure, including the rebar, metal wall panels, and any other conductive components, must be bonded together. Secondly, metallic equipment associated with the pool, such as the pump motor, filter housing, heater, and any underwater lighting fixtures, must also be bonded. Thirdly, any metallic parts within 5 feet of the inside edge of the pool, such as fences, ladders, and diving board supports, must be bonded. The bonding conductor is typically a solid copper wire, and it must be sized according to the requirements of the National Electrical Code. The size of the bonding conductor depends on the size of the service conductors supplying power to the pool equipment. The bonding connections must be made using listed connectors suitable for direct burial, and they should be accessible for inspection and maintenance. The connections must be mechanically strong and electrically conductive to ensure a reliable bond. When installing the bonding conductor in polyvinyl chloride conduit, it's crucial to ensure that the conductor is securely attached to the conduit throughout its entire length. This can be achieved by using cable ties or other suitable fasteners. The polyvinyl chloride conduit protects the bonding conductor from physical damage and corrosion. The depth of the polyvinyl chloride conduit must be at least 12 inches to comply with the National Electrical Code requirements for buried wiring. While the National Electrical Code does not specifically require sealing the bonding conductor connections, it's a good practice to do so, especially in corrosive environments or where the connections are exposed to moisture. Sealing the connections helps to prevent corrosion and maintain the integrity of the bonding system. There are several types of sealing compounds available, such as silicone caulk or electrical sealant. Choose a sealing compound that is compatible with the bonding conductor and the surrounding materials. Table 300.5 of the National Electrical Code provides requirements for the minimum cover depth of underground wiring. However, this table does not apply to bonding conductors, as they are not considered wiring in the same sense as circuit conductors. Bonding conductors are installed for the purpose of creating an equipotential plane, not for carrying electrical current under normal conditions. Article 250 of the National Electrical Code covers grounding and bonding requirements, and it provides specific guidelines for the installation of bonding conductors. It's essential to follow these guidelines to ensure compliance and safety. The grounding electrode system for the pool equipment must be connected to the bonding conductor. The grounding electrode system typically consists of a ground rod or a ground ring. The grounding electrode system provides a path for fault current to return to the source, tripping the circuit breaker or ground fault circuit interrupter. The size of the grounding electrode conductor must be sized according to the requirements of the National Electrical Code. The grounding electrode conductor connects the grounding electrode system to the service equipment. It's also important to consider the presence of other underground metallic structures near the pool, such as gas pipes or water pipes. These structures must also be bonded to the pool bonding system to prevent stray voltage from entering the pool area. Stray voltage can be caused by faults in the electrical system or by inductive coupling from nearby power lines. The bonding conductor should be sized appropriately for the maximum fault current that could occur. The fault current is the amount of current that would flow in the event of a short circuit or ground fault. The size of the bonding conductor must be sufficient to safely carry the fault current without overheating or causing a fire. To determine the appropriate size of the bonding conductor, consult the National Electrical Code or a qualified electrical engineer. The National Electrical Code provides tables that specify the minimum size of the bonding conductor based on the size of the service conductors. Fiber optic lighting systems used in pools must also be installed in accordance with the National Electrical Code. Fiber optic cables do not conduct electricity, but the power supply for the lighting system must be properly grounded and bonded. The power supply should be located at least 5 feet from the inside edge of the pool, or it must be protected by ground fault circuit interrupter. Ladders and other metallic accessories used in pools must be bonded to the pool bonding system. This helps to prevent stray voltage from entering the pool area. The bonding connections should be made using listed connectors suitable for direct burial, and they should be accessible for inspection and maintenance. Filter pumps used in pools must also be bonded to the pool bonding system. The pump motor should be grounded to the equipment grounding conductor in the circuit. The bonding connections should be made using listed connectors suitable for direct burial, and they should be accessible for inspection and maintenance. It's important to periodically inspect the pool bonding system to ensure that it is in good condition. Check the bonding connections for corrosion or damage, and repair or replace any defective component. The bonding system should be inspected at least once a year, or more frequently if the pool is located in a corrosive environment. If you are not comfortable working with electricity, it's best to hire a qualified electrician to install or inspect the pool bonding system. An electrician can ensure that the bonding system is installed correctly and that it meets all applicable codes and regulations. Proper bonding of an in-ground pool is essential for safety, and it's important to follow the National Electrical Code requirements to ensure compliance and protection. Remember to consult the latest edition of the National Electrical Code for the most up-to-date information on bonding and grounding requirements for swimming pools. If you have any questions or concerns about pool bonding, consult a qualified electrician or electrical inspector. Firstly, ensure all metallic parts are bonded. Secondly, confirm proper conductor size. Thirdly, check connections for corrosion. This attention to detail ensures a safe and enjoyable pool environment for everyone. The goal is to create an environment where the risk of electrical shock is minimized. This involves understanding and implementing the requirements outlined in Article 680 of the National Electrical Code. Remember that the National Electrical Code is updated regularly, so it's important to stay informed of the latest changes and revisions. The bonding conductor is a critical component of the pool's electrical safety system. It's responsible for creating a low impedance path for fault current to flow back to the source, tripping the circuit breaker or ground fault circuit interrupter. The bonding conductor must be sized appropriately for the maximum fault current that could occur, and it must be installed in accordance with the National Electrical Code requirements. When selecting a sealing compound for bonding conductor connections, choose a product that is specifically designed for electrical applications. These sealing compounds are typically non-conductive and resistant to moisture, corrosion, and chemicals. Apply the sealing compound liberally to the bonding connections to ensure a watertight seal. The sealing compound will help to protect the connections from corrosion and maintain the integrity of the bonding system. The grounding electrode system for the pool equipment should be inspected regularly to ensure that it is in good condition. Check the ground rod or ground ring for corrosion or damage, and repair or replace any defective components. The grounding electrode system should be tested periodically to ensure that it is providing adequate grounding protection. A ground resistance tester can be used to measure the resistance of the grounding electrode system. The resistance should be low enough to provide a reliable path for fault current to flow back to the source. If the resistance is too high, the grounding electrode system may need to be improved or replaced. When installing the bonding conductor in polyvinyl chloride conduit, use cable ties or other suitable fasteners to secure the conductor to the conduit. The cable ties should be spaced at regular intervals to prevent the conductor from sagging or pulling away from the conduit. The cable ties should be made of a durable material that is resistant to ultraviolet light and weathering. The polyvinyl chloride conduit should be installed in a trench that is at least 12 inches deep. The trench should be backfilled with soil that is free of rocks and debris. The soil should be compacted to provide support for the conduit. When making bonding connections, use listed connectors that are specifically designed for direct burial applications. These connectors are typically made of copper or brass and are designed to withstand the corrosive effects of soil and moisture. The connectors should be installed according to the manufacturer's instructions. The connections should be tightened securely to ensure a good electrical connection. After the bonding connections have been made, inspect them carefully to ensure that they are secure and properly installed. Check for any signs of corrosion or damage, and repair or replace any defective components. The bonding connections should be accessible for inspection and maintenance. If the connections are buried, they should be located in a handhole or junction box that is accessible from the surface. The handhole or junction box should be labeled to indicate that it contains bonding connections. The labeling will help to prevent accidental damage to the connections during excavation or other work. The size of the bonding conductor is determined by the size of the service conductor supplying power to the pool equipment. The National Electrical Code provides tables that specify the minimum size of the bonding conductor based on the size of the service conductors. The bonding conductor should be sized to carry the maximum fault current that could occur in the event of a short circuit or ground fault. The fault current is the amount of current that would flow in the event of a short circuit or ground fault. The size of the bonding conductor must be sufficient to safely carry the fault current without overheating or causing a fire. To determine the appropriate size of the bonding conductor, consult the National Electrical Code or a qualified electrical engineer. The National Electrical Code provides tables that specify the minimum size of the bonding conductor based on the size of the service conductors. When selecting a bonding conductor, choose a solid copper wire that is insulated with a durable, moisture-resistant material. The insulation should be rated for direct burial applications. The bonding conductor should be continuous, without any splices or breaks. If a splice is necessary, it should be made using a listed connector that is specifically designed for direct burial applications. The splice should be located in a handhole or junction box that is accessible from the surface.